Algebra 2, Linear Relations and Functions, Section 2.2. Here are today's objectives. Identify linear relations and functions. Write linear equations in standard form. Here is some of today's vocabulary. Linear relation, nonlinear relation, linear equation, linear function, standard form, y-intercept, and x-intercept. Function notation. Function notation is a way to name equations that begin with y equals. In function notation, we name functions with letters such as f, g, or h, and there's other letters that we use, but those are common ones. To name the equation y equals x, we can name it f of x is equal to x. Here we simply just replace the y with f of x. To name y equals 4x to the 6th minus 3x to the 5th plus 5x to the 4th plus 2x squared minus 1, we can name it g of x, where our g of x is equal to 4x to the 6th minus 3x to the 5th plus 5x to the 4th plus 2x squared minus 1. So as I kind of got tired reading that, one benefit of function notation is that we can just now use f of x or g of x to describe a function rather than reading every part of it. So this may not have been a huge deal when it came to our f of x, because that would have just been y is equal to x. It actually might cause us to say more stuff now that it's function notation, but I digress. On the other hand, our g of x, which is g of x is equal to 4x to the 6th minus 3x to the 5th plus 5x to the 4th plus 2x squared minus 1. Now instead of reading all of this junk, we can go ahead and just say g of x. And we know that g of x is equal to all of that stuff. And we can save ourselves a lot of time because we're math people. And math people are lazy. We don't want to do more than we have to. All right, linear equations are equations that have both x and y. This is a second cut here, so there's some things already going on here. All right, anyway. Linear equations are equations that have both x and y variables raised to not the 0th power, that was a typo, to the first power. And then here I've got some examples of linear equations. So some of them are 2x. Here I kind of wrote in that 1 to show that it's the first power. Minus 3y, once again I wrote in that 1, equals 14. And likewise, let me go ahead and just erase those. Now you can see that they weren't actually there. Also, we have x equals y minus 1. Once again, those are to the first power. We don't like to write those ones because, well, we're math people. We're lazy. We don't want to have to do more than we have to, as I can tell by your homework turn-in rates. And y equals 1/2 x plus 9. Once again, this is another linear equation. This one is actually in my preferred form here. We will get to this in a later section, but some of you might recall this is y equals mx plus b. Examples of nonlinear equations are y equals x cubed. So in this case, the x is to the 3rd power. X squared plus y squared equals 9. So here both the x and the y are raised to the 2nd power. And then also y equals the square root of x minus 81. Here there is also a power. We'll get to that in a few more chapters, but just keep in mind that if you see a square root over an x, that is in fact a power. State whether each function is a linear function. Write yes or no, then explain. All right, for A, going right ahead, I'm going to say yes. Now, you might not see a y here, but that's what the f of x is. So here I'm going to say both x and y are raised with a D, not a T, to the first power. All right, I'm going to write down B down here so that way my answers don't fall on each other. For B, I'm going to say no. And this is because this x, really, this is actually a 2x to the negative 1. It might be a 1 power, but it's a negative 1 power, so it doesn't actually fit the bill. So the answer is no. The x is raised to the negative 1 power. And then lastly, we have C. So C doesn't really follow anything that we've done before. We've got an x times a y. And then we have this g of x, y thing. So I'm going to go ahead and just say no. And even though this doesn't fall under what we had said earlier, it is one of those special cases. It's going to be because x and y are being multiplied together. So with our linear equations, x and y aren't ever being multiplied together. So that's why that one is not a function. So in this case, just a was a function. All right, we have our example 2. The growth rate of a sample of Bermuda grass is given by the function f of x is equal to 5.9x plus 3.25, where f of x is the total height in inches, x days after an initial measurement. So how tall is the sample after 3 days? All right, so we have how tall is the sample after 3 days? I had to pause there because I didn't bring a calculator home, so I'd use my computer to calculate some things. So in order to do this, we're going to be doing a, which is going to be f of 3, which, if you recall from the last video, this is just a direction to say plug in 3 to all of your x's. In this case, there's just one. So that's going to be a 5.9 times 3 plus 3.25. And if we use our calculator, we find out that this ends up just being a 20.95 inches. Well, that's some tall grass. That grass is close to being 2 feet tall. All right. Let's see. So for B, it says the term 3.25 in the function represents the height of the grass when it was initially measured. So they had just mowed the lawn. They found out with a ruler the grass was 3¼ inches. The sample is how many times taller after 3 days? So here I'm going to just take our answer. I'm going to do our 20.95. I'm going to divide it by a 3.25. And I'm going to get something approximately, yes, that's my approximate sign. It's not equals to, but it's approximately. Something approximately 6.45 times larger. Now, I don't know much about Bermuda grass, but that's some fast-growing grass if that's the case. All right, standard form. Any linear equation can be written in standard form. ax plus by equals c, where a, b, and c are integers, they're whole numbers, with a greatest common factor of 1, meaning they are not multiples of each other. We cannot divide them all by something. All right, let's do this. Example 3. Write -3/10 x equals 8y minus 15 in standard form. All right, well, let's write down the problem first. -3/10 x equals 8y minus 15. So right away, I see two problems here. We need to rearrange some things, but also we have a fraction. I'm going to get rid of that fraction. I'm going to multiply everything here by 10. For those of you who aren't used to this, this is my lazy way of saying I'm multiplying the entire equation. If it helps, you can always just go ahead and rewrite this as two sets of parentheses multiplied by 10. So here, this first one, I'm going to multiply that. We're going to get a 10 divided by 10, so we're going to end up with a -3x equals. Now, multiplying that into there, we're going to get an 80y. Multiplying it again, we're going to get a -150. All right. So right away, I can tell you that we do not have a common multiple besides 1. Yes, 80 and 50 can be reduced, but the 3 cannot be. All three of them need to be the same, so we can just move on. Now that we no longer have fractions, which I know some of you are like, oh, thank goodness. Let's go ahead and get this into standard form. Our standard form is ax plus by equals c. So I'm going to subtract 80y from both sides and get -3x minus 80y equals -150. I'm going to do one more step. I'm going to make sure these are all positive integers. I'm going to, this time, multiply them all by -1. So when I distribute that, I get a 3x instead of a -3x. I get a plus 80y. And then distributing one more time way over there, I'm going to get equals a positive 150. So now we're in standard form. We have integers. They're all positive, which is best, because technically they did have that greatest common factor of a -1. And they're in the form that we have up above. All right, intercepts. The x and y intercepts happen when the other variable is 0. So the x-intercept is where the y is 0, or the ordered pair of x, 0. There's a 0 in the y's place. The y-intercept is where x is 0, or 0, y, where 0 is in the x place. So this is a surefire way to get you your x and y intercepts. You just take the other variable and you make it a 0. We'll be doing a lot of this year. Example 4. Find the x and y intercepts of the graph of 2x minus 3y equals 8. Then graph the equation. All right, spoiler alert, I don't like this one. We're going to get a decimal, but whatever, okay. So what I'm going to do is I'm going to go first put this into standard form and get 2x minus 3y equals -8. Personally, I would have preferred that -8 being a 6 if I'm using intercepts, but not everything's how I want it to be. So now what I'm going to do is I'm going to take two things here. I'm going to first rewrite it. Second, I'm going to plug in 0 for the x. Because it becomes 0, I'm just going to not write the x. So I'm going to get, ideally, 2 times 0, which just leaves me with a negative 3y equals negative 8. Now I can divide both sides by negative 3 and get y equals a positive 8/3. Sad panda. All right, for the next one, I'm going to plug in 0 for the y. So negative 3 times 0 is 0, so I end up with a 2x equals negative 8. Then going to divide by 2 and get x is equal to negative 4. Or we get the ordered pairs of 0, 8/3 and negative 4, 0. Now we can graph. All right, so looking at my x's here, I know that 1 goes kind of far off into the negative 4 direction. And then 8/3 for the y, that's almost 3. So I'm going to go ahead and I'm going to make my graph something like this, where I've got room both up and to the left, so that way I don't have to worry too much about running out of space. This is a good step. Always look ahead to see what you need to actually graph, because you don't have to always look at the same place on each graph. So 0 and 8/3. So if I were to divide that, I'd end up with a 2.67. So I'm going to try to graph that the best I can. So 1, 2, I'm going to say right about there. Looks like about half, but whatever. And then we're going to have a negative 4, 0. Get a point right about there. And now we just graphed 2 points, whereas last section we graphed 3. I slightly missed. Whatever. Roots. We're going to use a lot of roots this year. The solution of an equation is called the root of the equation. Usually when we're talking about roots, we're talking about the x value. Usually when we're looking for roots, we make the y be 0. So in a way, if I go backwards a little bit right here, this would have been the root of the equation, because our roots are usually where we cross the x-axis. All right. So here we go. Our y is a 0. So find the root of 0 equals 5x minus 10. All right, this will be pretty fast, and then we're done. So I'm going to add 10 to both sides. Get 10 is equal to 5x. Divide both sides by 5. And get x is equal to 2. That's our root. Or as an ordered pair, it would be 2, 0. That could also be an answer. All right, that last one was kind of fast, but you know what? We're done. Congratulations. Next.